My name is Muhammad Shamir Marika, and today I'll be giving a presentation on IoT security. The four main IoT protocols that concern an IoT protocol model are Zigbee, Message Queue Telemetry Transport Control, or MQTT for short, Transmission Control Protocol, or TCP for short, and Constraint Application Protocol, or COAP for short. Zigbee is commonly used for communication and applications such as internet, transport, and other applications. It is frequently used in sports and fitness trackers, personal chronic monitoring, and several medical and scientific equipment. It is one of the most widely used protocols in home automation as well, where it is used for smart metering and smart grid monitoring. MQTT is an open message protocol that helps distribute telemetry information. It is able to accommodate CPU limitations and is great for preventative maintenance and real-time analytics. It is very crucial for monitoring in important environments. TCP consists of two main layers, transport layer and the routing protocol. Data is demanded and acknowledged via function using the TCP protocol. TCP also supports error and control flow, multiplexing and demultiplexing of data. TCP is a timeout-based retransmission. It uses timeout-based retransmission and DUPAC-based transmission. TCP is used for transmission of data in various fields, such as business and hospitals. COAP is a common web transfer protocol that is used for constrained nodes. COAP works for devices that are of similar or the same network types. COAP is very efficient for machine-to-machine communication. And COAP is a very good choice for many companies, such as industrial automation and other different various sectors, as it is a low overhead cost option. An example of an attack that can occur concerning TCP or lack thereof is a TCP reset attack. This attack takes place when an attacker sends forged TCP reset packets to a host that can then act to shut down the websites that are non-compliant with the attacker's demands. TCP reset can be used to carry out a denial of service attack. The TCP reset packet is usually used when another computer is not communicating effectively. During a normal TCP reset packet transfer, the receiving computer will send the packet. However, in a malicious setting, the sending computer will send the TCP reset packet. We can take preventative measures to reduce the risk and impact of such TCP reset attacks. Microblocks help disperse information at a slower rate to every SYN demand. Reset cookies help to ensure that a network can recognize the request as genuine, lock the client, and accept a verified approaching command. Stack tweaking acts by reducing the impact of a SYN flood attack if it were to occur. Stack tweaking works by changing the TCP stacks regularly and decreasing the break until the stack allows memory to be allocated to an association. Stride threat modeling consists of identifying 6 key forms of attack: spoofing, tampering, repudiation, information or disclosure, denial of service, and elevation of privileges. These attack vectors are some of the major ways that attackers can breach security in a network to gain the information that they need or make changes to a legitimate source. Spoofing is used by an attacker to disguise their identity as a legitimate one to gain access to confidential data. Types of spoofing attacks such as session hijacking, cross-site forgery, and cookie replay attacks work in several ways to mask as a legitimate identity and steal or edit data without authorization. Tampering is the change of a software in a network to allow the attacker to gain access and carry a denial of service attack on the server. Tampering attacks such as SQL injections or cross-site scripting can damage the integrity of a network. A repudiation attack occurs when an attacker can make changes to data and use it to forge identification, log incorrect data, or deny actions of authorized users. Information disclosure occurs when an application mistakenly divulges details that an attacker could then use to compromise the system. Information disclosure can happen when a developer leaves comments or other data such as source code exposed. The attacker can then use this data to force access into a network and gather information to further their malicious interests. Denial of service targets a network by flooding the network with traffic, triggering a crash, and shutting down to authorize traffic. DOS attacks can target both network and application layers of a network. Escalation of privileges attack is when an attacker uses vulnerabilities in a network to grant access to data. This can make data visible to unauthorized persons and result in a security breach for the company or business using the network. A smart home is a residence that utilizes IoT technology to connect and control various appliances and devices remotely. To model a denial of service attack on the smart home network, I have used Cisco simulation of a smart network to depict how traffic congestions can trigger an attack. As we can see in the diagram, the network consists of 4 PCs, a switch, and a server. All devices are running on the same subnet mask. Using the traffic generator, we can simulate the sending of an overwhelming amount of connection requests. This will then serve to crash the system to the attacker's wish. When the connections are all in place and the server is run, all connections are turned down or rejected, resulting in a crash in the whole system. This renders the system unusable for authorized users. This will result in a denial of service to legitimate users and therefore give attackers an upper hand in stealing the information or conducting a ransomware attack. Once a server is denied of service, the attacker can then steal information or threaten legitimate users with data leakage. Here are a few of the sources I have used, and I hope my presentation was worthwhile. Thank you.